Ne sumnjam da ste se bar jednom zapitali šta se dešava sa telom astronauta kada odu na višemesečnu misiju u svemir. Možda već znate da su istraživanja pokazala da u orbiti za svega 6 meseci čovekovo telo ostari gotovo 40 godina. Takođe, nakon šestomesečnog boravka u svemiru, mišićna masa astronauta je slična onoj 80-godišnjeg starca. To je verovatno najpoznatiji problem koji se javlja u bestežinskom stanju. U proseku astronauti mesečno izgube od 1 do 2% koštane mase, dok se masa mišića smanjuje čak za 5% nedeljno. Po povratku na Zemlju njihovo telo je toliko oslabljeno da im je neophodna pomoć i pri izlasku iz modula s kojim su se vratili. Oporavak najčešće traje onoliko dana ili meseci koliko su proveli u kosmosu, a jedini lek je uporno vežbanje. Naučnici iz Evropske svemirske agencije poslali su crve na šestomesečno putovanje svemirom da bi saznali kako se oni prilagođavaju životu u Sunčevom sistemu. Otkrili su nešto što može da bude veoma značajno za regeneraciju mišića ljudi na Zemlji.
Space station's been very good in that it's actually given us very good access to being able to study what happens in response to microgravity, and particularly to do so over a long duration. So for example, we've done an experiment where we've grown worms on the space station for 6 months. And that's longer than anybody's grown any animal in terms of the number of generations. So we know, for example, that we could potentially send biological specimens to Mars and see whether they actually would survive the trip. One of the interesting things with the worms is they seem to adapt to living on the space station just like we think the astronauts do. And that's an interesting problem if we think about health in our society. People are changing their diets, they're changing their habits. You have people like me who are a bit overweight because perhaps we eat too much of things that we shouldn't and we don't exercise enough. So one of the things that underlies a lot of that adaptation is changes in metabolism. And so clinically we see this as a problem with things like diabetes and obesity. So by trying to understand the mechanisms that allow the worm to adapt to a new environment, to change its metabolism, maybe we can find out how the worm adapts its metabolism to other situations which might be relevant to things like obesity and diabetes. So far we've learned that worms seem to adapt to the environment of the space station, and they use similar signaling pathways that they use on Earth to adapt to things. And one of the things that's interesting about that is that pathway is also involved in regulating the lifespan of the worm. The other thing that we've learned from studying worms on the space station is that they have special protein complexes in the muscles that actually allow them to shrink, and we think that those attachment complexes are actually important in the normal regeneration of human muscle here on Earth. But if I had to choose something wild and exciting to do, I'd like to actually send worms to Mars or somewhere else to see if we could actually grow an animal on another planet.
Pitanje koje muči ljude još od kad su shvatili da je Zemlja okrugla je da li smo jedini stanovnici ovog Sunčevog sistema? Da li bi život mogao da postoji još negde van Zemlje? Astrobiolozi iz Evropske svemirske agencije ne bi bili astrobiolozi kada bi dozvolili da ih ovo pitanje muči. Nisu bili lenji, izvršili su različite eksperimente pokušavajući da pronađu nove vrste mikroba koje bi bile otporne na ekstremne uslove u svemiru. Jer sve počinje od mikroba, očigledno. Prvo da saznamo da li mikrobi mogu da rastu u ozračenom okruženju Marsa, na primjer, pa ćemo lako mi da se spakujemo i naselimo tamo. Ipak, možda još nije vreme da napuštamo Zemlju. Hajde prvo da vidimo šta su astrobiolozi do sada otkrili.
Astrobiology is a very interdisciplinary field, but it's very exciting because it looks at life at the limits and tries to understand whether life could exist elsewhere. Astrobiologists are also trying to find new types of microbes that could be resistant to space extremes. Can we find new microbes that would be useful in space exploration and settlement? And are we the only example of life in the universe, or are there other planets with life? These are fundamental questions, but they also have very practical implications. By learning about life in extremes, we learn about the interaction of life with our own planetary biosphere. That might tell us about the human impact on the biosphere in the future and the future of life on Earth. By using the International Space Station to look at the limits of radiation stress in microbes, we might learn something about whether microbes could grow under the radiation environment of Mars, for example, or in other planetary bodies. There's a couple of experiments we've done. One experiment is to expose microbes to space conditions. This is a European experiment called the EXPOSE experiment, where we take microbes onto the space station, we bolt them onto the outside of the station and leave them there for 1.5 years, 2 years, and see which ones can survive the intense conditions in space. Over a quarter of the world's copper and gold is today extracted from rocks using microorganisms. It's called biological mining or biomining. And the question is, could we use microbes elsewhere in space to try and extract elements from rocks? The bio-rock experiment was motivated by trying to understand how microbes interact with rocks. Now, you might think that's a very strange thing to have an interest in, but it turns out this is very important. For example, we could use rocks on the Moon, Mars, or asteroids to supply microbes in life support systems that might be producing oxygen or other useful elements and compounds for human existence. We also want to understand how microbes behave inside, for example, filter systems that are circulating fluids and liquids, drinking water. If you're relying on microbes to produce oxygen, for example, for your astronauts, you don't want all the microbes to suddenly die. So you need reliability. So despite the fact they can survive in extremes, we still need to understand how they behave in space and how we can optimize their chances of surviving in space conditions. If I had any wish in space exploration, it would be to try and grow microbes on the Moon or Mars and try and do the real experiments. We can do these experiments on the International Space Station, but these experiments are partly to prepare humans to go to asteroids, the Moon or Mars. So the ideal experiment would be to actually go to these places and grow microbes in the environments in which we actually want to use them.
Međunarodna svemirska stanica je naseljen satelit koji se nalazi u niskoj zemljinoj orbiti na oko 360 km od površine Zemlje. Stanica zapravo predstavlja svemirsku istraživačku laboratoriju za mikrogravitaciju, čiji članovi posade vrše istraživanje iz oblasti biologije, ljudske biologije, fizike, astronomije, meteorologije i drugih oblasti. Iako ovu letelicu možemo uočiti na nebu, ne možemo baš sve videti golim okom. Naprimer, od čega žive astronauti dok borave u svemirskoj stanici? Znamo da ih kiseonikom i vodom snabdevaju svemirske agencije sa Zemlje, ali u budućnosti i tokom dužih misija to neće biti moguće. U Evropskoj svemirskoj agenciji se već razmišlja o rešenju ovog problema.
For us, ISS is actually the ultimate test platform because you have the combination of all the space conditioned parameters, including the higher doses of radiation as well as the microgravity effects. Currently, the crew is very much depending on supplies from Earth, so they get the water, the oxygen they need from Earth. In the future, in long-term missions, this will not be possible anymore. So one of the development is to recycle the water and the oxygen as much as possible, to reuse it over and over. Currently we are investigating a bacteria which is actually a kind of microalgae, which is a photosynthetic microorganism which is capable of producing oxygen, and finally the biomass you make is also edible, so finally the crew would be able to eat it. We are investigating how bacteria are growing and evolving and behaving in space conditions, because we know how they grow on Earth, but we don't know how they adapt really to gravity, low gravity and higher ionizing radiation in space. Different scientists and European investigator groups have sent bacteria to space to investigate how they grow there and how they evolve. But we have seen that depending on the bacterium you choose and the culture condition you choose, also the reaction of the bacterium may change. Melissa is a project where we try to develop a technology which allows the astronaut to produce its own oxygen, water and food, actually by taking the waste and reusing the waste in a very efficient way. To do that, Melissa has different chemical techniques, different physical techniques, but also biology reactors, or what we call greenhouses and bacterial growth chambers. If we can better understand how we can miniaturize these kind of water recycling processes using bacteria, for example, on small scale, independent, definitely we can also use this technology on Earth to improve our daily water purification systems. But the final goal would be to demonstrate that we can do this kind of growing of bacteria, growing of plants also on the moon. So for us, if one day we could do this kind of flight experiments on the moon's surface, I think would be a major milestone.
Biljke zauzimaju važno mesto u našem svakodnevnom životu. Ok, nekima samo ukrašavaju prostor, ali ne zaboravite da biljke proizvode i kiseonik i vodu i na kraju mogu biti i hrana. Na Zemlji je to sve lako. Posadimo seme i koren raste na dole u potrazi za vodom i hranjivim materijama. Ali u kom pravcu će se koren razvijati kada ne postoji gravitacija i očigledan smer? Kako bi pronašli odgovor na ovo pitanje, naučnici su posadili seme u Međunarodnu svemirsku stanicu i otkrili su da gravitacija uopšte nije ključna odrednica u određivanju uzorka rasta biljke. Sada kada to znaju, kakvi su im dalji planovi? Hoće li biti nekih baštica na Mesecu?
Well, everybody knows that plants are important for the daily life on the earth, for the daily life of the human being. For the same reason, really, plants are important for any adventure of space exploration that the human being can undertake. Plants produce oxygen, which is an essential component for our life. Plants produce water, which is also essential. Plants produce fundamental food. We are now using the fantastic resources offered by the International Space Station, which are just being now fully available from even in the case of Europe, with the implementation of the Columbus Laboratory, which is an unprecedented tool for biological, which is in general for scientific research, but in particular for biological and more particularly for plant research. Gravity is an essential factor for the growth of plants. Roots grow downwards and stems grow outwards because of the presence of the gravity vector. When this vector is absent, as in space, this process is totally disorganized. And the study of the particular cellular and molecular mechanisms of this process is essential to be capable of successfully growing plants in the future in the conditions of microgravity that exist in space. European scientists have developed a fundamental role in the discrimination of these cellular and molecular mechanisms. Then the next step is to pass from the model plant that we are now using, Arabidopsis, is a plant that nobody is interested in except plant scientists because it's the model. So to pass to plants of economical value, such as rice or wheat or cereals in general, soya bean, plants which are interesting for human food. And then the next step is to produce a space garden or a special space culture capable of producing a crop capable of being eaten or being taken by astronauts as their food, and also an interesting factor as a psychological relief. And we will be capable of producing plants that will be able of growing deeper in the soil, or on the contrary, which the roots growing more horizontally And this is very important in terms of the capability of taking the water which is being found deeper or at the surface of the soil. So really the purpose, the objective, is really to translate the Earth garden to Mars or to the Moon or to the interior of the space station or to whatever space vehicle or whatever space planet or space habitat that the human being can put their feet on